All of the previous partial fractions examples I did had unique terms in the denominators. In other words, each denominator was different from each other denominator. We're going to look at a partial fractions problem that involves a denominator that has some terms that are repeated. Okay, so let's say you factored a denominator and you ended up getting x times the quantity x minus 1 times the quantity x minus 1 times the quantity x minus 1, or quantity x minus 1 cubed. Okay, so you have x minus 1s being repeated. Unfortunately, you can't just do a fraction with an x minus 1 and an x. Okay, life is going to be a little bit more complicated. Now, each of these individual factors is still a linear term. Okay, we just have x's in each of these factors. As a result, we're still going to be able to break it up with just one constant value in the numerator. Okay, the thing that's going to change is that you have to list every possible power of your repeated term as a possible denominator. And it's pretty complicated to explain why this has to occur, but if you try looking at some number values and adding up different fractions, like if you add up sixths to equal something like 5/6, and then you try this with something like 12 that has a repeated factor of 2, you can kind of feel out why this works. I'm not going to put that in this video though. Anyway, the way this is going to work then, basically you have a variable that's going to be over x, okay, so some constant over x, okay, and then you're going to have an x minus 1 term, okay, so you'll have a b over x minus 1, okay, but you have to have an x minus 1 squared term, and there's the possibility of having an x minus 1 cubed term, okay? So again, since each of these factors is something that's linear, you're still just going to end up with constants in the numerator, but life does get a little bit more complicated with these problems. Okay, so I'm going to do the same thing I've been doing in the last few problems. I'm going to multiply the numerator by the common denominator. So I'm going to multiply the numerator here by x times the quantity x minus 1 cubed. I'm going to multiply this by x times the quantity x minus 1 cubed. I'm going to multiply this by x times the quantity x minus 1 cubed. I'm going to multiply this by x times the quantity x minus 1 cubed, and I'm going to multiply this by x times the quantity x minus 1 cubed, okay? And the whole idea here is, number one, we'll knock out denominators. Number two, lots of cancellation, all right? So here, all of the denominators cancel out. We're just left with an x squared plus 1, okay? Over here, just the x cancels. We're going to be left with an a times x minus 1 cubed. X minus 1 cubed is x cubed minus 3x squared plus 3x plus 1. Sorry, minus 1, if you go through the whole process there. And so, anyway, it'll be a times that. Okay, 1x minus 1 will cancel one of the x minus 1's there. So you'll have x times x minus 1 squared, okay? X minus 1 squared is x squared minus 2x plus 1. That whole thing is being multiplied by x. So that's going to be an x cubed minus 2x squared plus x, okay, being multiplied by b. So I have plus b times x cubed minus 2x squared plus x, okay? Two of these x minus 1's are going to cancel two of these x minus 1's. It's going to leave you with a single x minus 1. That simplifies to be x squared minus x being multiplied by c. So we've got c times x squared minus x. And then finally, all of these cancel all of those. You're just going to be left with a dx. Okay? So again, it's big, it's long, it's complicated. We're going to have to do a lot of simplifying. Okay? So what I'm going to do here is I'm going to multiply all of this out, and I'm going to try to group everything together. I want my x cubed terms together, I want my x squared terms together, I want my x terms together, and I want my constant terms together. So I have x squared plus 1 is equal to, now my cubed term, I'm going to have an ax cubed term, I'm going to have a bx cubed term, and I'm not going to have any cubed terms from those last parts. So that's my cubed terms, okay? Now my squared terms. I'm going to get minus 3 ax squared, okay? Here I'm going to get minus 2bx squared. Here I'm going to get plus cx squared, and I won't have any x squared terms coming from that, okay? Now I need my x terms. We're going to get a times 3x, so plus 3ax. We're going to get b times x. We're going to get minus c times x, and we're going to get plus dx, okay? And then finally, constant terms, we'll have a minus a, and I know I'm running out of space here, this may go off screen. Constant term there, won't be a constant term here, won't be a constant term there, won't be a constant term there. So that's all we have to do there. All right, so what's going to happen here? This is really 0x cubed plus x squared plus 0x plus 1. Okay, so the coefficient of the x cubed term needs to be 0. The coefficient of the x term needs to be 0. Okay, what does that tell me? Well, here my x cubed terms are. That tells me that a plus b has to be equal to 0. Okay, tells me that my x term has to be 0. Okay, if I look down here at my x terms, it's going to be complicated. It's going to tell me that 3a plus b minus c plus d is going to have to equal 0. Okay? It's telling me that my x squared terms, I need to have 1x squared. Okay? So if we look at my x squared terms here, it's telling me that negative 3a minus 2b plus c is going to need to add up to equal 1x squared. And then finally, my constant term needs to be 1. Well, I only have one constant term. It's just that negative a. So negative a needs to equal 1. And by the way, that tells me something very important. If negative a is equal to 1, that means that a is equal to negative 1. Okay? And I can substitute that back into a lot of my equations, and I can find other values very quickly. So if a is supposed to be negative 1, negative 1 plus b is 0. That means b is supposed to be equal to positive 1. Okay? Let's find my easiest equation to deal with a c here. I guess it's this one. So a is negative 1 here. B is positive 1 here. That's going to be negative 3 plus 1. Oh, there's a d there. I don't want to use that one. Sorry, just kidding. We'll put a negative 1 into this equation, and we'll put a 1 in for b there. And so as a result, we're going to get 3 minus 2b, 3 minus 2 plus c is equal to 1. 3 minus 2 is 1, so that's telling me that c is equal to 0, okay? And I should be able to find my d value now. We can put it back into here. If c is 0, that's going to be negative 3 plus 1. There's no c, plus d is equal to 0. Negative 3 plus 1 is negative 2. That means d is going to need to equal 2. Okay? And we should be able to fit everything back into the original equation. Again, it's kind of a mess here. You can see the original one up there. Let's piece all this together. So the original version of this was a over x. So that would be negative 1 over x. Plus b over x minus 1. That would be 1 over x minus 1. Plus c, c is 0, so it would be 0 over x minus 1 squared. So I'm not going to write that term. And then finally, plus d, my d value here is 2 over x minus 1 cubed, okay? And that would be my final partial fraction decomposition. So a challenging problem, not super common, but something you'll see from time to time.